Hey there, and welcome back to part 3 of the Easy LeetCode challenge. So we have another 10 videos today. So let's get started. We have best time to buy and sell stock, given array prices, price size, the price of a stock on that day. You can choose to maximize your profit, return the maximum profit. Okay, so this one's pretty straightforward. So profit equals 0, and then the price we bought at, we want to maximize it at the start, I think, so we can buy lower. So because our profit is going to be sell minus buy, so for price and price bought equals min, we want to always buy the minimum, so float, or not float in, this is bought price profit equals always maximize profit of price minus bought turn profit. Okay, so it's just basically we just always want to be buying low and selling high. Okay. All right. So remove duplicates from a sorted array, given an integer, remove duplicates in place such that each unique element placed only once, relative order of the elements to be the same. Okay, so we have, okay, so what we want is we want some number that's outside of range, so let's just say minus 1,000. So last num or something goes minus 1,000, or you can even make it like this, doesn't matter. And so when we remove duplicates, what do? Do we put them in the end, or does it not matter? Of order. Then return the number of unique elements. So we have this k thing again, 0. Then we have a write to, same kind of thing that we had in some other. So for in the range length nums, if nums I does not equal the last number, then write nums write to equals nums I equals nums I. Okay. I guess technically this is the same thing, so I can probably actually get rid of this and just use this. So we just write to k. Okay. All right. Straightforward. Move zeros. Move all zeros to the end while maintaining the relative order. Let's do it in place. So same thing. We can just have a write 2 equals 0, and then we can have a k where anytime we hit a 0, we so I think we might need to have a different k, but not entirely sure. So for nums, what we need to do is we need to, if I does not equal 0, 2 equals nums I, 2 plus equals 1. Technically, yeah, I think we probably don't need this k actually. So then we also need to write the zeros to the end. So how many zeros do we have total? So anytime we write in a 0, we'll increment that. Okay, so we can just do something like this. Right, 2 is greater than 0. And then we can just have it like this, and then we can keep decrementing. So nums index equals 0, index minus equals 1, right, 2 minus equals 1. Something like that. And then do we need to return? No. Okay. So what do we have? Okay, we wrote it too many times. That's interesting. So how do we do this? So write 2 equals 0. If nums I equals 0, nums write 2, write 2 plus equals 1. Yeah. While write 2. Oh, I see. This is the problem. Yeah, so if nums I does not equal 0, then write 2. Okay, so actually we have a couple issues here. So this write 2 shouldn't be that. This should be that. Nums write 2 equals nums I. So this is when it's not 0, we need to write it. Write 2 plus equals 1, and then we have a k. Let's just have a k that we increment otherwise. So this is k, k, k. Okay, there we go. So we just increment the number of zeros. We can have a better solution, but for just doing these fast, that works. Okay, so you're given two integers, nums I and nums 2, and we merge them and we decrease in final sort array should not be sorted. Instead should be sorted in array nums1 to accommodate this. Nums1 has an array length of m plus n, where m is, okay, I see. Okay, so in this case, write 2 is going to be length of nums1 minus 1, so that's going to be the first place we're going to be writing to, and then m plus n. So m is 3. So actually what we want is we want to do this, and this is the index that we're going to be writing from now. Yeah, so we're going to be writing from both of these, and then while m is greater than 0 and n is greater than 0 equal to. So when they're both, if nums1 m, and then if they're equal, it doesn't matter where we write from. So nums1 is less than nums2 n, then nums1 right 2 equals nums1 m. Yeah. Okay, and then else, oh, and we have to decrement m here. Else nums1 nums2 n minus equals 1. Okay, so we decrement them both. This is fine. Yeah. Now we have to make sure that pretty much we could have finished one of these lists, so we have to make sure if there's anything left. So while this, oh, and by the way, we also, yeah, so we also forgot to increment our right 2. It's going to be, is it minus equal? Yeah, because we're writing to the back. Yeah. Okay. So while m is greater than 0, we just do this. And this. And same thing for n. So we make sure that we finished both of those lists. Minus 2n. We can have a more elegant solution for sure, but this is just faster. And time complexity will be the same. Okay, so this is n. Right, 2. Okay. Now, interesting. 2, 5, 6, 1, 2, 3. Okay, so how did that happen? So we're doing this first, which is kind of interesting. So m is that if nums1 of m is less than, oh, I see the problem. So we actually need to do this in reverse because we're writing backwards. So we need to write the biggest number. Okay. Reverse string. So to reverse a string, it's kind of like checking for a palindrome. We just have 2 pointers on the left and on the right, and we just keep swapping until we get to the middle. So and also, I think what we want to do, yeah, so because it's a string, oh, it's actually a list, never mind, so we don't even need to worry about that. I was going to say, because if it's a string, if we're reversing these letters in Python, strings are immutable, so you don't want to do that. You want to have a list, but we already have a list. So in that case, it's just s left. We can do this in one line. S right equals s right s left. Okay, and then we just decrement. So left equals 1, right minus equals 1. It should be that. We don't need to return. Okay. All right. So the minimum difference between highest and lowest k scores, given an index array, number scores I student, you're given an integer k, pick the score k, such the difference at the highest and the lowest is minimized. Okay, so I think here we're going to want to sort. We're going to sort the numbers, and then our k is going to be the size of our list. So because if they're sorted, we're just going to go through every combination of k elements and get the min and the max, and then figure out the smallest. So res. So we're looking for a minimum combination here, which means we're going to want res to be the max. I'm going to start off. So okay. Left is going to be 0. Yeah. And right is going to be k. No, it's going to be k minus 1, I think. Because for one element, yeah, from one element we want it to be 0. Okay. And then it's just simply going to be, so if we have some kind of thing like 1, 4, 7, 9, it's going to be the right element minus the left is going to be the difference between the highest and the lowest. So while right is less than nums, res equals min res nums right minus nums left. Okay. Then we just increment everything here. So left plus equals 1, right plus equals 1, and return res. Good old Python with a random tabbing. Okay. Alright, that one's pretty straightforward. Valid palindrome 2. Given string s, return true if s can be a palindrome after deleting at most one character. ABA is true, ABCA. Okay, so we're going to do a palindrome check, and then if there is a character that we can try to delete, every time there's a character we can... I don't even think if there every time there's a character we can try to delete. As soon as we hit a character we can try to delete. Does it matter which one we delete? That is the question. So if we have a string like, what would be something? So like A, B, C, and then we have, or here, let's say, or let's just say like A, B, C, then we have D, and then we have E, F, G, let's say, and now we go F, E, and then this is just like an A or something like that. CBA. So we get to two characters that are this A and this D, and we have to delete one. So our left is here, our left is here, our right is here. Our right is here. And then we have to delete one, and we just try. Yeah, okay. So if we delete one, we just take the left two parts of the word and we say, is that a palindrome? Does it matter which one we delete? I think so. Yeah, definitely does. So we have to try both. Okay. So anytime we get to an unmatching pair, we have to try both, and then we have to... Yeah, and then let's just make a helper function as well. So def pal s. So this is where we can check if it's a palindrome or not. So left, right equals 0. Lang s. Minus 1. Left. So it's standard palindrome. So if s left is not equal s right, return false. Left equals 1, right. Okay, so that's going to be our helper function, and then we're going to do the same. We're going to loop through this palindrome and then see if we do have a mismatch, and if we have a mismatch, we're going to call this pal. So let's do that. So same thing here, left, right equals 0. Technically, I think we could call pal with the string, and then we can pass in the substrings, but that's fine. I think this is easier because then we have the one check. So when this code's going to be the same, while left, doesn't right. So if we have one error, it's okay, but if not, then so if we have one error, we're just going to pass into pal. So if s left does not equal s right, that means we have to check the string. We can either delete left or right. So if pal s, so if we delete left but we include right, it would be like this: +1, right, +1, or pal, then now we do include left but we don't include right. So we can try deleting either one. We pass that into palindrome. So if we do include left, that's going to look like this. Then we can return true and then return false here. Okay, so as soon as we run into something wrong, we call palindrome on both the combinations where we try to delete one letter or the other if there's a mismatch. And then we're done. So like in this case, we would pass it in with, well, this B and C doesn't match, so then we would try to pass in ACA and ABA, and if one of those works, then we're good. Okay, and then now we just have to increment as well here, so once again, you can probably write this a little bit more efficiently, but just for the sake of time, then return true here if we didn't have anything, and return true here if we didn't have anything as well. Okay. So pass left. Okay. Alright. So pretty straightforward. So normal valid palindrome. Okay, so now the difference is there are letters that aren't alphanumeric. So we have to take care of that. So, okay, but it's going to be the same way. So left, right equals 0 when s minus 1, while left is less than right. Okay, so now what we have to do is we have to make sure the letters are working. So if s left is alnum or something, I actually do want to look up alnum. Yeah, I think it's just like this. Num. Okay, so I think if it's not, so if it's not alphanumeric, then we can just go forward. Equals 1, and we don't have to check, and then elif. Not s r is alnum. Yeah. Okay. So then if that's not alphanumeric, then we go back. If else. Okay, so elif here, s. Now we just check for equality. R, right. So if they're unequal, then it's not a palindrome, so return false. Okay, and then else. Yeah, so if we incremented one of them here, we don't want to increment that again. So if they are equal, then we just do this standard. So return true. Okay, once again we have Python. Okay. Oh, we do have a bug. So Zalnum. Kind of want to look up the Zalnum real quick. So name is, oh yeah, I think I missed. sorry, my mic cut out there. So I think, guess this is wrong. Oh, there's one more thing. So when I check these, I need to do to lower because they could be uppercase. So if they are characters, I want to compare them both to lower. So this algorithm does work. It checks for alphanumeric. Okay. All right. And next one. Find the index of a first occurrence in a string. Okay, so this is we're just gonna go through this whole with this whole thing with a left and a right pointer, and it's gonna be equal to the size of this word, and then we're gonna check is our current window that we're in equal to the word. So left, same thing, sliding window equals 0. Length of needle, screen -1 here. And then while right is less than 1, same thing, sliding window. There's a lot of sliding window and easy problems. If needle, no, haystack. So left, and then it needs to go to right. So it would be like this. Equals needle, return true. If our sliding window is correct, otherwise we just increment. So left 1, turn false if we couldn't find it. Ooh. Okay. Oh, so we want return the first occurrence. Okay, so if it's the first occurrence, we return left, I believe. Yeah, and then return -1. So I think it was right. I just returned the wrong output. Okay. And then design hash map. So design hash map, we need to have a put, key, update. Okay, so we're going to have an array and array of arrays, and because this is 10 to the 6th, we're going to make an array of 10 to the 3rd, and then each array is going to have another array in that. So that'll kind of roughly divide it up. Okay, so let's do that. So what we need to do is we need to have self.map. Map is a keyword, so probably don't want that. Probably want something like this. Equals empty array. So I think this would be more efficient with linked list, but because it's an easy, we'll just use an array for I in range 1000. Okay, so now let's see here. Put inserts a key value parent to the hash map if it exists in the map to the corresponding value. Okay. So what we need to do is we need to figure out where it would go, and so index equals key modded by 1000 because that's where that's where it would go. Now we need to iterate through the entire array in there, so bucket or something equals hash map at index for I in range length bucket if bucket I, and so the bucket is going to have a key and a value, so the value is going to be the second item. Where you need to update the value if there's a key. So if bucket I0 equals key, then we update the value here. So bucket I1 equals value, and then we return, what do we return? It's a void, so just return. Okay, and if there is no key, then we need to add it to the bucket. So bucket dot append, and then we're going to append key value. Okay, so that's the put. The get returns a value. Okay, so this is going to be kind of similar, so we're just going to take some of this code compared to the put. So it's going to be the same index, bucket. If bucket equals key, then we return the value. So then we just return value here. Bucket I1 is going to be the value. and then we return 0. We couldn't find it. Or what do we return? -1. Removes the key. So yeah, this is going to be a little bit slow because it's an easy problem, but that's okay. And it's going to be similar to this put, same thing. So we're going to find it. We're going to go in here. If bucket equals key, then we're going to need to remove right here. So we need to remove this from the hash map. And I think the way we do that is bucket.pop index I, and then we just return. Moves the key. If otherwise, we don't need to do anything. So I think that's good. Dot solution. What do we got here? For I in range. Okay. Probably have that in all of them. Yeah, so let's just copy this. Okay. So equals same. Okay. So self dot hash map. Love copying code 3 times and then you get the same error everywhere. It's pretty great. Okay. So now let's go over the time and space complexity for all these problems, and then we will be done. So for best time and sell stock, we are just going through this array, and we're simply saying if there's a price lower than what we bought at, then we buy at this price, and then we try to see what can we sell at this location. So for example, we would go through here and we'd say, well, our initial starting price is infinity, so 7 is lower than infinity, so we try to buy at 7, then we sell at 7, so it's a profit of 0. Then we go to this 1 and we say, okay, 1's lower than 7, so we're going to buy at 1. Then we're going to go here and we're going to keep our 1, but our profit here would be 4. And then we're going to keep our 1 throughout because that's the lowest price we could buy. So our profit here would be 4, it would be 2, it would be 5. So 5 would be the biggest value, 3. So we're just iterating through this array and we don't have any other data structures we made. So time is O of n, space is O of 1. Okay. So let me just actually copy this so I can not have to. Okay, so for this one, remove duplicates from a sorted array. So we're just going through the array and we are writing in numbers that aren't a duplicate. So we just remember the last number we wrote, and if the last number we wrote is the same number we're on, then we skip. Otherwise, we can write it in. So we're just writing in from the array into a write to location. So that's going to be the same. We're just iterating. We're not making anything new. I guess that's a nice thing for all these easies is most of these are just big O of n and big O of 1. Here, move zeros is pretty much the same thing as the last one. You can optimize the total number of operations if you figure out what's the optimal way to move zeros to the back, because you probably are doing some duplicate work. So you can definitely optimize that. And if you want me to do something on this problem to minimize operations, you can let me know in the comments. But the time and the space would be the same because we're just going through it one time. Space is O of 1. And even if we minimize operations, our time complexity would be the same because let's say we're not going through this array twice now or something. We're going through it, a little bit less, but time and space complexity would all be the same. Okay, so merge sorted array. We are going through both of these arrays. So the time and space complexity is going to be, we're going through this whole bit, and then we're going through this whole bit. And we're writing to this array. So we're going to be writing the length of this nums1 array. So the times is going to be, if n is the length of nums1, then our time is going to be nums1. And then the space, we didn't make any new data structures. And so for this, we basically just say, while we actually have 2 places to write from, write the smallest. But then once we run out of 2 places to write from, one of these is going to be at the start. So then we figure out what else do we have left to write, and one of these is going to be non-empty. So we just have these 2 loops. You can change this code, and instead of these 2 loops, you can just check this stuff in this, and it'll be a little bit cleaner. But that's for that one. Reverse string is the same thing as check for a palindrome. You just have a left and a right pointer, and you swap them every time. So you just say left is right and right is left until you hit a middle. Same thing, time O of n, space O of n, or space O of 1, we're not making anything else. Minimum difference between height of lowest k-scores. So we have a sliding window, which is going to be big O of n, same thing again. Our space is O of 1, we didn't make any other data structures, so that's that. Valid palindrome, So our time is going to be, once we do hit a letter that we're not sure to remove, we are splitting the word into a left word and a right word. But a left word and a right word would be something like 2n, so our time would still be ov(n). But we are making a left word and a right word, so I think we are making a new data structure here. So we are making a string that we're passing in because we're doing that. Technically, what we could do actually for his ov(1) solution, so let's do that real quick actually. So instead of this s, let's just pass in an l and a right. So instead of passing in this whole chunk, we can just pass in the indices of the left and the right. So if we want the left and the right, let's say, if they're not equal, let's just start at left. Then we do right minus 1. And then here we do left plus 1. So instead of making a new substring by slicing, we can just pass in indices directly, and that will give us an ov(1) solution. So let's change this code up a little bit. So we don't need this left-right. Now we already have values, and then we have access to this string s, I believe. So if SL is not equal right, return false, and then this should just be this, and I think that should work. So now we did make our solution ov(1). Okay. All right. Valid palindrome, same thing as the other one, except this is just even the easier one. So find the index of the first occurrence in a string. So this is a sliding window as well. Yeah, so this is a sliding window as well. And so we're going to be iterating through this whole haystack, but we're not making any new data structures, so that's that. Design hash map. Okay, so this one is going to be a little bit different. So we are making an array of size, so it would be 10 to the third, and then each array is going to have subarrays. And so I'm not sure the most number of elements we can have. Does it say? I guess it would just be 10 to the 6th value. No, actually no. This is the okay, so at most 10 to the 4th calls will be made to put get and remove. And so we're making an array of arrays, and each array is going to have a key value. So the most it can ever be is if we just put in 10 to the 4th elements and they're all unique, then the space is going to be 10 to the 4th elements. And then the time wise, so let's think about this. So worst case scenario, if we have 1,000 different places we could put it, basically what we're doing is we have a really simple hash function where we're taking the key, we're modding it by 1,000, and we're trying to put it in to our buckets. And so the most keys that can be in the same buckets are, if it goes up to, so 10 to the 6 is 100,000. No, is it 100,000? No, I think it's a million. Yeah, 10 to the 6 is a million. Yeah, 6 zeros. So we can technically have the most items we can have in one bucket is 1,000. And so if we're putting in the same worst case scenario, we're putting in a million. We're only putting in 10,000 items, but worst case scenario, 1,000 of those items go into the same bucket. If we're putting items into the same bucket, then each put is going to take a long time because we're going to have to iterate through the same array. So I think worst case scenario here, it'll be something like, for put, anyway, let's just say for put. If we're putting in 1,000 items in, every time we're going to iterate through 1,000 items. So the iteration of one put will be 1,000. It'll be less to start off, but so it'll be something like 1,000 times 1,000 is what the big O is going to be, assuming these are the sizes, if we're filling up an entire bucket. So what we can do to minimize that maybe is have even a bigger having a bigger hash map, but then we'd also have to sacrifice space for that. And then space, yeah, I think there's 10 to the 4th items total. So because we have an array of arrays, I think it would be something like this, where it's 10 to the 4th items. And then, so let's figure out. So put would be this. Get would be worst case scenario. We have a bucket of 1,000 items. So get would be big O of 1,000, I think. Yeah, because we have to check through 1,000, so it would be that. And then, well, put actually, sorry. So put would technically be the worst case 1,000 as well, because we're only putting in one item. But when we do a bunch of these operations, that's when it would be bad. So each put is 1,000, and then if we have 1,000 or 10,000, so remove. Yeah, so remove, we're doing the same thing, and then we might have to resize the list. So it might be something like big O of 2 times 1,000, but that would still be 1,000. So each one of these operations, I think, is big O of 1,000, and then we have 10,000 operations. So that's why worst case scenario we can be putting in 1,000 items into the same thing. So it's something like that. Each one of these, I don't think you're asked of like what would be the time complexity of putting in 10,000 items, but each operation would have the time complexity of however many items your bucket can store. And let me think if you can make something. I mean, you can definitely make something more efficient, obviously, because a put operation in a normal hash map is big O of 1, and then get is big O of 1, and things like that. But I think the way this is handled is these bucket, like um, if we have multiple collisions in a real hash map, then it gets resized. So if you want it, but that would be way harder than an easy problem. So something like if you get multiple items in the same bucket over and over and over, then you just change your hash scheme where you make sure your items are well distributed, so you avoid having a ton of items in the same bucket. And yeah, you can look up the way I think Python hash maps are made is there's an array beneath the surface, and whenever there's enough collisions, it'll resize, or whenever more than half of the buckets are full, it'll resize and things like that. So it keeps it efficient. You're never going to get these issues, but for this case, that's what it is. Okay, so I think that's everything for these easy problems, and I'm gonna do some more of these in the future. So if you like this stuff, like and subscribe, and I appreciate it. It helps the channel grow, and I'll see you in the next video.